Hello class. Coming back part 2 of lesson 18, 19, and 20 in the Alchemy unit. Uh, from the first lesson, from part 1, we learned that everything in group 1, let me highlight group 1 for us. It's group 1, everything in group 1 has 1 outer electron. Everything in group 2 has 2 outer electrons. Everything in group 13 has 3 outer electrons. Everything in group 14 has 4 outer electrons. Everything in group 15 has 5 outer electrons. Everything in group 16 has 6 outer electrons. Everything in group 17 has 7 outer electrons. Oops. And everything in group 18 has 8 outer electrons. Everything wants to get 8 outer electrons. And so, because group 18 already has 8 outer electrons, these are called the noble gases. The reason why they're called the noble gases is because they do not react with anything, because they have the magic number 8, they have a full octet, and so therefore they don't need to react with anything because they're already happy or stable. So the things that don't have 8 outer electrons are not happy, they're not stable, and therefore they are going to react with other elements to either lose electrons or to gain electrons so that they can get a full outer energy level. So let's take a look at magnesium number 12. Magnesium number 12 has 12 protons and 12 electrons. The first 2 electrons go in the first energy level. And to try to figure out how many energy levels we need, period 1, everything in period 1 needs 1 shell. Everything in period 2, the second row, has 2 shells. Everything in period 3 has 3 shells. So because magnesium's in group period 3, we know that magnesium is going to need 3 shells. Because it's in group 2, we know it's going to have 2 outer electrons. So 2 will go in the first, 8 will go in the second. But magnesium starts out 12 electrons, so 2 plus 8 is 10. So we know that magnesium is going to need to have 2 electrons in the third energy level. Alright, so here we go. What are the options? How can magnesium become like a noble gas and get 8 in this outer ring? Well, it has 2 outer electrons. It wants 8. So it could either gain 6, steal 6 from other atoms, or it could lose 2. What do you think would be easier? To gain 6 or lose 2? It would definitely be easier for it to lose 2. And so magnesium will have these 2 electrons stolen, the outer 2 most electrons stolen. And when that happens, we see that it now has 8 electrons in its outermost energy level, which is now the second. So this magnesium is happy, but it lost 2 electrons. So it no longer has 12 electrons anymore. It now has 10 electrons. It starts out, it has 12 protons. We know that because the atomic number is 12. And so now if we look at our magnesium, it's no longer neutral because the protons and the electrons are not equal anymore. So therefore, what will the charge of magnesium be? Magnesium, when it's happy, when it's stable, has a full outer ring, is going to be a positive 2, plus 2, because there's 2 extra protons compared to electrons. So magnesium have a plus 2 charge. Now because everything else in magnesium's family has 2 outer electrons, everything else, beryllium, calcium, strontium, they're all going to be 2 plus 2 because they all have 2 outer electrons. They're all going to lose those 2 electrons. So now let's go through and let's figure out what the charge of each family will be when it's happy, when it's stable. Group 1 has 1 outer electron, so it's going to lose the 1 outer electron. So everything in group 1 is going to be positive 1 when it's happy, when it's stable. Everything in group 2 we just saw has 2 outer electrons. It's easier for it to lose 2 than to gain 6. So everything in group 2 is going to have a positive 2 charge. Group 13 all have 3 outer electrons. These things are all going to be 3 positive because they're going to lose 3 electrons instead of gain 5. Group 14 has 4 outer electrons. It could either gain 4 or lose 4. If it loses 4 electrons, it'll be plus 4. If it gains 4 electrons, it'll be minus 4. Now it gets a little bit tricky here. Things in group 15 have 5 outer electrons. So instead of losing 5, it's easier for them to steal 3 or to gain 3. So if they gain 3 electrons, they're all going to have a -3 charge. And we'll come back and we'll look at one of those. Group 8 or group 16 all has 6 outer electrons. So they're going to gain 2. If they gain 2 negative electrons, they'll be -2. Group 17 all starts out with 7 outer electrons. They all need to gain 1. So if they gain 1 negative, they'll be -1. And then group 18, they already have 8 outer electrons. So therefore, they'll always be neutral. They'll always have a 0 charge. So let's go back and let's take a look at, let's say, oxygen. Oxygen starts out with 8 protons and 8 electrons. It's in group 16, so we know it has 6 outer electrons. It's in the second period, so therefore we know it has 2 shells. Two electrons will fill up the first energy level first. It has a total of 8 electrons. 2 are in the first. Therefore 6 are going to be in the second. It wants to have 8, so therefore it needs to steal 2 electrons from other atoms. And if it gains 2, if it steals 2, it's now going to have 10 electrons. 8 protons, 10 electrons. It has 2 more electrons. Therefore, the charge of oxygen is going to be 2-. So we write the symbol oxygen, and we write 2- because it now has 2 extra electrons when it's happy and stable, when it's like a noble gas. And that is exactly what we saw here. We said that it should be 2- when it's happy, and it is. This ends part 2. Part 3 is coming up next.